Hello and welcome to this quick clip on a long answer infrared and mass spec A-level question. It's actually an older specification question, being 8 marks on offer rather than the normal 6 marks. So I'll take you through it anyway because it's a nice introductory way of thinking about how to structure your answer. So your chemist was provided with a compound J which has an unbranched carbon skeleton. Now they actually mention the fact it's unbranched twice, once up here and once a bit further down. So I think that's probably quite important to bear in mind when we're coming up with a structure a bit later on. So looking at the table, there's 3 types of analysis that were used. So your answer really needs to have 3 sections to it. So you can deal with each one separately and individually. So let's look at the infrared information first. It says there's a broad absorption at 3350 centimeters to the -1. So a quick check of the data sheet reveals 2 possible candidates, either an NH bond or an OH bond. But if we look at the elements, you can see there's no nitrogen present, so therefore it's probably not going to be an amine or an amide. So that leaves us with an alcohol as a possible candidate here. So we can now put in our IR spec analysis. Broad absorption at 3350 centimeters to the -1, likely to be the OH bond. So notice I'm not saying whether it's a carboxylic acid or an alcohol yet. I'm literally just putting down the OH bond. When we have more information to piece together, we can decide if it's a carboxylic acid or not. So the first thing to do with the percentage composition by mass is to divide each of the percentages by the relative atomic mass of the element. So you can see that with carbon, for example, we get 5.8825. And then for hydrogen, 13.72. For oxygen, 0.980625. We need to change those into whole numbers. So you divide by the smallest to do that. So you'll notice I put an approximate equal sign, not an absolute equal sign. That's because in the first 2 cases, it's approximately 6. I think it ends up at about 5.9 something. And then it's nearly 14, for example, for hydrogen. So you can round up. So obviously, a number divided by itself gives you an absolute value of 1. So that now allows us to say the empirical formula for this compound is C6H14O. So from the mass spectrum, we know that there's a molecular ion peak at MZ102. So if we have a look at the MR, that's normally going to be the molecular ion peak. So we don't have to go any further with the mass spec analysis on that. So now we've got some information we can start to collect together to come up with possible structures. Now, have a look. It says suggest all the possible structures for the unbranched compound J. So the mass of the empirical formula is 102. The MZ value of the molecular ion is also 102. So the MR must be 102 grams per mole. So that means matching those 2 together, they're the same number. So the molecular formula must also be C6H14O. So we can say we've got 6 carbon atoms in a chain because it's unbranched. We know it's 6 carbon atoms because the molecular formula tells that to us. There's only 1 oxygen available, so it can only be an OH group. It can't be a carboxylic acid because that would require 2 oxygens. So our possible structures are hexane 1-ol, hexane 2-ol, and hexane 3-ol. Remembering, of course, that you have to draw the structures out to get the credit, not just put the names down. Okay, hopefully this has been a useful look at how to unpick this question. Thanks for listening. Until next time, see you soon.